pressure is a force. Air does take up space and it does have mass. Even though you cannot see it, it does take up space and it does have mass. Now, air molecules move very fast. The more air molecules you have in a specific amount of area, the higher the pressure is. So if you look at this diagram right here, this is a hot air balloon inside of the air, in the atmosphere. So on the inside the air, inside the hot air balloon, you can see that there's a lot less molecules and they're moving a little faster. Outside, there is a lot more air molecules and they're moving a little slower. It goes back to this experiment that I did earlier. What allows one balloon to blow up and what doesn't allow the other balloon to blow up is air pressure. Now both of these bottles have exactly 1 atmosphere of air pressure in it. Now when I try to blow up, this one. When I try to blow up this balloon, it does not blow up. This is because the air inside of the balloon is stopping that from happening. The air inside of the bottle, I'm sorry, is stopping that from happening. The air, excuse me, the air pressure has constant push on the balloon. And when I try to blow up the air, it's trying to push out. But the air inside the bottle is pushing back at the exact same force, which does not allow the balloon to expand. Now with this, if you notice, if you inspected this bottle very carefully, I poked holes in the bottle of this bottle.
I didn't know that.
You were right there when I did it. I poked holes in the bottom of this bottle. And this allows for air to escape when I try to blow up this balloon. So when that air escapes, there's not the same amount of pressure pushing back on the balloon. The air is escaping, so it allows the balloon to expand. This happens also in the atmosphere. This happens also in the atmosphere. So like when you are, a low pressure system allows the air to leave, and it allows for buoyancy in the atmosphere and allows for storms to form. In a high pressure system, much like this, nothing rises, nothing forms. There's no buoyancy or there's no buoyancy, nothing to get the clouds to grow. So this experiment or this event, this rapid event, is directly related to storms. Just
So the high pressure is synonymous to the light moving slower?
yes,
Okay.
yes. So what did anyone write in the W part of the KW? What you want to know about air pressure?
So what is it measured? How is it measured?
Air pressure is measured in several different forms. You have atmospheres, that's how we usually measure in the United States. Meteorologists measure it in pascals, hectopascals. They also measure it in millibars, so it's definitely different units to measure it in. The most common that you see on TV is millibars, and that's the most common. And they also measure it in inches, mercury inches as well. Is there anything else someone wants to know?
What type of atmosphere is like hurricanes and tornadoes form? Would it be the low because things can form?
Yes, so going back to this, the only way the balloon can expand was in a low, with the pressure like the air pressure leaving in a low pressure environment. So with hurricanes and tornadoes and any other weather that is not fair, you need some type of low pressure system. Most of the time you need some type of low pressure system to help that air to leave and things to rise, like the air can rise and then cool and form clouds, thunderstorms and whatnot. And that works perfectly in a hurricane. Yes, ma'am.
Does air pressure affect your lungs in any way? Does it actually expand?
Yes, our lungs, like if you ever go swimming, if you ever went deep sea diving, you know that your lungs can collapse if you don't breathe right because of the pressure difference between the air in your lungs and the water around you. So if you see when I blow this up, this one right here that actually blows up, when I blow it up and then I let go, the bottle itself is going to crush on itself because of the pressure that left the bottle. And you can watch it over time. And the bottle like pretty much crushes itself because of the pressure. And the same thing can happen to your lungs because the pressure difference pressure difference inside the balloon and outside the room is so great that it crushes it. And same thing can happen in your lungs, to your lungs.